Hello students, welcome to the fifth session of this chapter number system. Before these 4 sessions, we have already discussed about review of natural numbers, whole numbers, integers, rational numbers and irrational numbers. Their decimal expression, representation of their decimal values in the line number line, real numbers as terminating and non-terminating decimals, condition for terminating the decimal expressions. Along with that, we have also covered the operation of rational numbers and irrational numbers and rationalization of the expressions whose denominators are in irrational form. Now today, we will recall the laws of exponents and will use the term laws of rational indices for using these laws of exponents to laws of rational indices. So what the laws will come from laws of exponents to laws of rational indices, how it will change and how it will be used in real numbers, today we will learn it. Okay. After completion of this session, we expect that you will be recall these laws of exponents. You will be able to simplify the real numbers by using the laws of exponents. Apply these laws of exponents for rational indices also. Okay, what the laws of exponents we have learned in the previous class? Let us see. We have learned some exponents, some laws of exponents, like first law is a to the power m into a to the power n is equal to a to the power m plus n. We have discussed this, a to the power m into a to the power n equal to a to the power m plus n. Similarly, the next law we have learned, a to the power m divided by a to the power n, this is equal to a to the power m minus n. Next is, we'll learn a to the power m and whole raised to the power n is equal to a to the power m into n or a to the power mn. Similarly, next law what we have discussed, it is a to the power m into b to the power m is equal to a into b whole to the power m. These are some laws we have already covered in the previous classes. Here this a, b, m, n, all we are taking as natural numbers. We were taking as natural numbers. But now we are discussing about real numbers. So how this can be used in real numbers? So let us observe. In addition to all these things, if I need to express a to the power 0, so how I will express a to the power 0? So let us see now. When I write a to the power 0, what I have to write? I have to write a to the power 0. Using these laws of exponents what we have discussed, I can write a to the power 0 equal to a to the power m minus m. Because I know 0 comes m minus m. When I subtract the same numbers from here, so it will be a to the power 0. But a to the power m minus m, this comes from, I can write a to the power m minus m comes from a to the power m by, sorry, a to the power m divided by a to the power m. That means a to the power m minus m comes from a to the power m divided by a to the power m. Looking at this expression, we can understand in this rational expression, in the numerator and denominator, both the same number of a are multiplied. If I can extend, you will find it is a into a into a. Similarly, m number of times it is multiplied. M times it is multiplied. Similarly, in the denominator, I find it is a into a into a. It is also m times multiplied. If you find all these factors are same as the numerator and denominator, you can cancel all these factors and you will find finally it is 1. So finally what I get, a to the power 0 equal to 1. I can write it here, a to the power 0 equal to 1. Okay. So how I got a to the power 0 equal to 1? Using the same laws of exponents we understood now. But if we need to express a to the power minus 1, then what changes will be happen in the same law? Let us see again. If I want to make a to the power minus 1, I will write a to the power minus 1 is equal to, in the same format if I want to write a to the power m minus n form. So here I have to choose a m such that m will be less than n and it will be less than 1, less than n by 1. So I will choose it here, m must be less than n and m will be equal to n minus 1. So choosing such type of m, so let me take it here, a to the power minus 1 is equal to, I will take it here a equal to 2 minus, here n I will choose as 3. So a to the power 2 minus 3, that means a to the power minus 1. Now what do you mean by a to the power 2 minus 3? Using the laws of exponent we will find out here. This will be a to the power 2 minus 3 can be written as a to the power 2 divided by a to the power 3. Opening this expression now we'll find there are 2a in the numerator while there are 3a is multiplied in the denominator. Now cancelling these factors from the numerator and denominator, I will find finally the answer is 1 by a, because this a will be cancelled with this a will be cancelled with this, and I will find numerator nothing will be left, only 1, and denominator only one factor will be left, that is a. So a to the power minus 1, finally I got it here 1 by a. So this is an expression we have derived from this laws of exponents. Okay, so from the laws of exponents we find that a to the power minus 1 is equal to 1 by a. If I will express a to the power minus 2, so how will I write a to the power minus 2 is equal to, with the same formula, a to the power m minus n. I can take it here, m must be less than n, and m I will select such that it will be less than 2 by n. So now I will select a to the power minus 2 is equal to a to the power 1 minus 3. So this I can write as a to the power 1 divided by a to the power 3. This I can write as a divided by a into a. And cancelling the common factors from both the numerator and denominator, I find it is 1 by a square. So finally what I get? A to the power minus 2 is equal to 1 by a square. Okay, so here I got to know that a to the power minus 1 is equal to 1 by a and a to the power minus 2 equal to 1 by a square. Similarly, I can write a to the power minus n equal to 1 by a to the power n. Okay, so this is the generalizations I can draw from these laws of exponents, what I get at here. Okay, so in this way we have expressed a to the power minus n equal to 1 by a to the power n. Now, for the a be a positive real number and n is a positive integer, let me check again. If I take a is a positive real number and n is a positive integer, for that nth root of a. So what do you mean by nth root of a? Let us discuss about this nth root of a. So this nth root of a expression can be expressed as, this value will be expressed as a b if b to the power n equal to a and b must be greater than 0. So b to the power n equal to a and b must be greater than 0. So converting this radical form, this is a radical form, converting this radical form to exponential form, we can say now, if I find b equal to a to the power n, b to the power n equal to a, we can write a to the power 1 by n equal to b, and this a to the power 1 by n is expressed as nth root of a. So finally what I get? Nth root of a is equal to a to the power 1 by n. Okay, so nth root of a we can express as a to the power 1 by n. Okay, so let us go for some example. Let us see how it happens. Let me give cube root of 2. This is cube root of 2. So if I write cube root of 2, it indicates that it is 2 to the power 1 by 3. If I write fourth root of 3, this indicates that it is 3 to the power 1 by 4. Okay, so this is the expression. If I write nth root of a, then nth root of a can be changed into exponential form as a to the power 1 by n. So cube root of 2 is written as 2 to the power 1 by 3. Fourth root of 3 is written as 3 to the power 1 by 4. Okay, similarly, suppose if I write change to 4 to the power 3 by 2. So here, instead of 1 by 2, I have written at here 3 by 2. So what will happen? So I will split this now in this form 4 to the power 3 whole to the power 1 by 2. So when it is a to the power m whole to the power n, the law of exponents we have used at here, it becomes now a to the power m into n, 3 into 1 by 2, 3 into 1 by 2, it becomes 3 by 2. So 4 to the power 3 by 2 I expressed as 4 to the power 3 whole to the power 1 by 2. Now in such case I can write this equal to, how much this I will write now? 4 to the power 3 already we got it is 64. And 64 whole to the power 1 by 2. 64 is already we know it is 8 square. We can write as here the 64 as 8 to the power 2 and whole to the power 1 by 2. Now again it is in the form of a to the power m whole to the power n. So here what will happen? We will find that here with the same base, these powers will multiplied. A to the power m into n, and when we multiply 2 into 1 by 2, it cancels. Finally, I got it is 8 to the power 1 and value is 8. So 4 to the power 3 by 2, I got it is 8. Okay, this is my answer. This was the initial expression what I wanted to find. Okay, 4 to the power 3 by 2, I wanted to find. I find it is 8. Okay, using this now 4 to the power 3 by 2, here the exponent is in a rational form. And using the same laws of exponent, I find this 4 to the power 3 by 2 as 8. Okay, so this I could do in the different methods. For example, 4 to the power 3 by 2, I could have written in this form. Let me write it as 4 to the power 1 by 2 first, then power 3. I could have changed these powers. Instead of 3 keeping inside and 1 by 2 outside, I will keep 1 by 2 inside, 3 keeping outside. So what will happen in that case? So I will find it is 4 to the power 1 by 2. 4 can be written as 2 to the power 2 whole to the power 1 by 2 and whole to the power 3. Now this 2 to the power 2 whole to the power 1 by 2 whole to the power 3, I can write as 2 to the power 1 by 2 and 2 into 1 by 2. This will be multiplied. It will be 2 into 1 by 2 with whole to the power 3. Now this expression you will find it is 2 because this 2 and 1 by 2 they will cancel. 2 to the power 1. 2 to the power 1 is only 2 whole to the power 3. So finally 2 to the power 3 becomes 8. In such case also we will find the same expression is called this, get the same value but in a different method. So this is the application of laws of exponents when you find the exponents are rational numbers. Okay, so from this expression we can find what we can get at here now. Now we can say for a greater than 0, let me write, for a greater than 0, m and n are the integers such that m and n doesn't have any common factors other than 1 and n greater than 0. So here m and n are the integers belong to z. Okay, integers such that m and n doesn't have any common factors other than 1 and n greater than 0. Sorry, n greater than here 0. In this case, we'll find a to the power, what I get at here now, a to the power m by n is equal to, it is nth root of a to the power m. Or I can say it is nth root of m to the power nth root of n. Either I can write m is inside of this nth root or I can write it is outside. Both of these gives the same value. A to the power m by n is nth root of a to the power m, or m to the power a to the power n, nth root of a to the power a whole to the power m. These two things. For example, I can go now 27 to the power 2 by 3. Suppose I will write it is 27 to the power 2 by 3. So how to find such type of example? So 27 to the power 2 by 3, I can write as 27 to the power 2 whole to the power 1 by 3. Now this I can write 27 to the power 2 whole to the power 1 by 3. This 27 I can write as 3 to the power 3 whole to the power 2 and whole to the power 1 by 3. Now here I can find 3 to the power 3. This 27 is converted as 3 to the power 3. Then power 2 is there already and 1 by 3 is already there. So converting that, I can write it here now. 3 to the power 3 into 2 into 1 by 3. So multiplying all these things simultaneously, I can find this 3 and 3 will be getting cancelled. So remaining will be 3 to the power 2 and finally it is 9. So what I get it here now, 27 to the power 2 by 3, it is equal to 9. Similarly, go for one more example. Let us see. If I take one more example, let us go for 64 by 125. 64 by 125 to the power minus 2 by 3. Suppose here I will take it as a minus 2 by 3. So how I will find it here now? So this indicates that if this base is already in the form of a rational expression, I can write 64 to the power minus 2 by 3 divided by 125 to the power minus 2 by 3. Okay, now opening this, I will find the 64 to the power minus 2 by 3, I can write as here, it is 8 to the power, sorry, it is 4 to the power 3. I know 64 is 4 to the power 3 whole to the power minus 2 by 3. Divided by 125 is 5 to the power 3. I can write it as 5 to the power 3 whole to the power minus 2 by 3. Okay, now I can write as 4 to the power 3 into minus 2 by 3 divided by 5 to the power 3 into minus 2 by 3. Now multiplying this 3 and 3 will be getting cancelled and this 3 and 3 will be getting cancelled. Finally, I will get it as 4 to the power minus 2 divided by 5 to the power minus 2. And this I can write as 4 by 5 whole to the power minus 2. As we have already know, a to the power minus 2 equal to 1 by a to the power 2. We have already seen. So we can use that here now. 4 by 5 whole to the power minus 2 is equal to 1 by 4 by 5 whole to the power 2. This I can write as 5 by 4 whole to the power 2. And finally, what I will get the answer? This will be 25 by 16. So I have started with this 64 by 125 whole to the power minus 2 by 3. And finally, I reached to the answer 25 by 16 whole to the power 25 by 16. So this was my question and this is my answer. I started with this example 64 by 125 to the power minus 2 by 3. With moving in the formula laws of exponent, I find finally it is 25 by 16. Okay. So in this way, if we go for the some more examples, we can be clear. If I'll write to simplify an expression is 4th root of 81. It is 4th root of 81. Then minus 8 into cube root of 216 plus 15 into 5th root of 32 and plus square root of 225. Okay, so this is my expression to write 4th root of 81 minus 8 into cube root of 216 plus 15th 15 into fifth root of 32 plus under root of 225. So how I will simplify this expression? Again, using the same laws of exponents, we have to do it. Okay. So looking at here, now fourth root of 81, I can write it here now. This will be 3 to the power 4 because 81 is 3 to the power 4, I know, and whole to the power 1 by 4. This fourth root of 81 can be converted as 1 by 4 minus 8 into this cube root of 216. This 216 I have converted as 6 to the power 3, and this cube root is converted as power 1 by 3. 15 into this 32 I will write as 2 to the power 5 whole to the power 1 by 5 plus 15 to the power 2 whole to the power 1 by 2. Now expressing this, I will find 3 to the power 4 into 1 by 4 minus 8 into 6 to the power 3 into 1 by 3 plus 15 into 2 to the power 5 into 1 by 5 plus 15 to the power 2 into 1 by 2. Now this 4 and 4 is getting cancelled. This 3 and 3 is also getting cancelled. 5 and 5 is also getting cancelled, and this 2 and 2 is getting cancelled. So finally what I get at here, 3 to the power 1 means 3 minus 8 into 6 to the power 1 means 6 only plus 15 into 2 to the power 1 means 2 plus 15. Okay, because 15 to the power 1 is there. So finally what I'll get at here now? So 3 minus 48 plus 30 plus 15. So this gives us 30 plus 15 plus 3. These are plus. So I will write it here is 48 minus 48, and this is equal to 0. So I have started with this expression and I reached it is 0. So simplifying all this expression by using laws of exponent, I find this answer, this expression's answer becomes 0. Okay, let us go for one more example. If we'll keep on using this simplification or laws of exponents, let us go for one more example. Simplifying 2 into x cube y to the power 4 whole into 3x y to the power 5 and whole to the power 2. Now, how to simplify this expression and convert it into a single term? Now, this is 2 into x to the power 3 into y to the power 4. Splitting this term individually, I can write it is 2 into x to the power 3 into y to the power 4. But here this entire expression has a power, another power 3. So this power 2 will be changed to every individual's power. So now 3 to the power 2 into x to the power 2 into y to the power 10. So this 2 becomes each individual term's power now. So I got it here, it is 2 into, okay. So this expression will be, it is x to the power 3 into y to the power 4 into this 3 to the power 2 is again converted as 9 into x to the power 2 into y to the power 10. So this I can write as this 2 into 9 is multiplied and it becomes 18 into x to the power 3 is multiplied again with x to the power 2. Y to the power 4 is multiplied with y to the power 10. Now this becomes now 18 into x to the power 3 will be added to this 2 because the same base is there. So it will be 2x to the power 5. Y to the power 4 is multiplied with y to the power 10 because the bases are same. So power will be added and it becomes now 14. So finally this is my expression. It is 18 into x to the power 5 y to the power 14. Okay, I have started with this expression. I reached to the 18 into x to the power 5 into y to the power 14. Okay, so this is another example. Let us go for one more example. Applying the same laws of exponents to the different examples, we'll find how different examples will be useful for the different questions. Okay, so let us simplify one more example. It is 1 to the power 3 plus 2 to the power 3 plus 3 to the power 3 and whole to the power 1 by 2. How will do this question now? Okay, so to do this question, we have to find this individual terms cube first. So 1 to the power 3, now we can write it as here 1. 2 to the power 3, because it is added at here, I cannot split this power to its individual terms power. Okay, so I have to find this entire value first. If it instead of addition, it would have been be multiplied, I could have given this power to each individual terms power. But now, as it is added, I have to find these values of this individual terms first. So 1 to the power 3 is 1, plus 2 to the power 3 becomes now 8, 3 to the power 3 becomes now 27, and whole to the power 1 by 2. This I can add now. 27 plus 8 is 35, plus 1 is 36, and whole to the power 1 by 2. So 36 already we know it is 6 to the power 2 and whole to the power 1 by 2. So multiplying a to the power m whole to the power n. So m and n are multiplied. So 2 into 1 by 2 will be multiplied and you will get it is 6 to the power 1. So finally the value will be 6. Okay. So this is another example where we have used this laws of exponent. Okay. Let us go to one more example. But here we'll find something different. Okay. Now in the next example, let us write 2 by 3 whole to the power x is multiplied with 3 by 2 whole to the power 2x. 2 by 3 whole to the power x multiplied with 3 by 2 whole to the power 2x gives us 81 by 16. Okay, in such case, how to solve these values of x? This is called an exponential equation. This is called exponential equation. Why it is called exponential equation? Because there is a variable whose value we have to find out and the variable is in an exponential form. Okay, that is why it is called exponential equation. So how to deal this type of questions now? So 2 by 3 whole to the power x is there, into 3 by 2 whole to the power 2x is there, and this side 81 and 16 is there. If you think 81 is can be converted as 3 power 4 and 16 can be converted as 2 to the power 4. That means this 2 can be converted as 3 to the power 4 by 2 to the power 4. So let me write down here. So I will give implied sign because I am going to solve it now. So 2 by 3 whole to the power x into 3 by 2 whole to the power 2x is equal to, now what I will do it here now, 81 by 16, this I can write as 3 to the power 4 divided by 2 to the power 4. Now here you'll find this is written 2 by 3, this is written 3 by 2, this is also 3 by 2 is coming. So what I will do not here, I wanted to change this 2 by 3 as 3 by 2. So what law of exponents will be used at here then? Laws of exponents we have learned, it is if a to the power minus 1, it is 1 by a, that I can use at here now. I will write here, this will be, instead of 2 by 3 to the power x, I can write 3 by 2 to the power minus x. If it will be 3 by 2 to the power minus x, if I open this, I will find it is 2 by 3 to the power x. That means 2 by 3 to the power x, I have changed to 3 by 2 to the power minus x. Into this term is remain as it is, 3 by 2 to the power 2x. This equal to 3 by 2 to the power 4. So why I have changed this? Because I wanted to make both the sides with the same base. So now what I get? 3 by 2 to the power. This is minus x and this is 2x because the both bases are same and the power has to be added. So it will be minus x plus 2x. This side equal to 3 by 2 to the power 4. So finally what I get at here now? 3 by 2 to the power x is equal to 3 by 2 to the power 4. This implies x equal to 4. This is my answer. Okay. By solving this way, we can also find the values of x. Okay. So here we learned at how to use this laws of exponents in the rational numbers. So all these real numbers can be also used as the powers, what we learned at here. Okay, so this is all about these laws of exponents we have discussed. Now what we discussed in throughout this all chapters. In all the chapters we have find a lots of things we have seen. We have started with the natural numbers, we reached to the whole numbers, then we moved to the integers, then we moved to the rational numbers, how to express the rational numbers on the number line, how to operate the rational numbers. Then from the rational numbers, we came to the need of irrational number. And what is the irrational number? How it is to be presented within the number line? Where does it lie? Do these irrational numbers are finite or infinite? We have seen how to represent these irrational numbers on the number line also. Then we started operating real numbers. All real numbers, addition with real numbers, subtraction, multiplication, division, we have seen. Then we came to rational expressions of these decimal expressions or rational numbers, real numbers, rational expressions. That means if it is expressed in decimal form, how it has to be converted into rational expression. Similarly, when it is expressed in rational form, how to be converted in decimal form. All these things we have discussed. Then we have to go for more some things. We have learned about the laws of exponents, and the laws of exponents, how it will be changed to the from natural number and whole number, how it is changed to the rational number and real number, we have also seen it here. This is all things we have to practice. A number of questions are given to you for practice more. Okay, you can see a number of questions will be given to you. Okay, through the worksheets given in the latter period, it will be given in the next sheet. You can find it here, and you can go for the practicing also. Okay, this is a small thing. You have to practice more. All these chapters we have discussed. So have a better practice. So thank you so much.